Great. Again, thank you everyone to hang out here in the afternoon for this session. We're very excited with this work. And I'll be presenting the work entitled Post-Fire Delay Mortality in Douglas-fir and Western Hemlock following the 2020 holiday farm fire at the Andrews. And I'll be presenting very preliminary results. While I'm presenting today here, this work is actually being led by April Hersey, which is an NSF REU undergrad student at PSU who couldn't attend today. So you're all familiar with the idea that we're having increased fires, but maybe you are not, or you assume, I've not seen this figure, that the 2020 wildfires actually are an amazing representations of the trends that we're seeing today across the West. So if we were to build a model around burn area and also droughty conditions, the 2020 really fits very well that model. And also that relationship is tightly to a warmer atmosphere, as we heard earlier this morning from Henry, that is largely due to atmospheric aridity and fuel aridity as well. So across the West, and particularly across southwestern US, we see more frequent and severe drought that has been observed in recent decades, as well as possible impacts of post-fire delay mortality. So increased post-fire delay mortality can substantially reduce the extent of fire refuge over time, as we heard from Matt, as we've heard also from Meg earlier, limiting natural tree regeneration that in turn can promote forest conversion to alternative or even non-forest states. As also Matt alluded, it's unknown really the effect of post-fire delay mortality can have on carbon sequestration and overall carbon dynamics on this west side very rich biomass forest. Previous work in dry forests, primarily in California but also in the southwestern US, have shown that extensive delay mortality due to pre-fire competition and drought was reflected in pre-fire reduced radial growth of the actual rings of the trees. But how does pre and perhaps also post-fire competition and drought, especially we think about the heat dome, affects radial growth in these trees in mesic west forests and ultimately also post-fire delay mortality? We expect that as Matt presented, there will be quite a bit of variation due to species traits and forest types. But we really don't know. 5 years prior to the 2020 Labor Days, we experienced a remarkable snow drought in 2015. And again, in 2021, an outstanding heat dome that, as David Shaw here, as the expert in the room, assured us we would expect substantial delay mortality due to it. So our overarching question and working hypothesis is that what are the patterns and possible drivers of post-fire mortality in mesic forest? And how do these patterns and drivers vary between iconic fire resistant from a trait perspective and also fire-sensitive conifer species? So here's, as you can see, we have time on the x-axis, radial growth of the trees. We have a snow drought in 2015, and trees get a hit, decline in tree growth. And then we have the 2020 fires, and then the trees that survive the fires actually then get pushed down like a double whammy by the heat wave. And so we're thinking about compounded stress of events. Our study design was fully conducted within the old growth that exists within the boundaries of watershed 2 at the Andrews. That is 400 or 500 or so years old growth, and where we had samples both Douglas-firs and fire-sensitive western hemlock. Our sampling to collect tree cores occur, again, here's the Andrews. This is the southwestern corner that, thank you, Cole, for the introductions to the Andrews. This actually is a burn severity conducted also in October, the month after the actual fire, where in yellow you see low severity all the way to high. We paired trees of each of those two species by life and death, of course using the species, but also the size. Many of these trees were so tall that we couldn't really see how tall they were, but from allometric equations that are common in the area, we started using DBHs as a proxy of how tall they were. We also controlled for slope, proximity between the life and dead ones, as well as also the remote sensing derived severity and also the char rating, or the charring really, rating near the ground line. As you can see, we tackled mostly trees that actually have been barely crawled. The Andrews was primarily, or this watershed was primarily burned during the non-windy second part of the 2020 fires. And so there was really no burn, and the crawling was just underneath. The actual boundary of the fires extends higher up, and the satellite sensors could not really even pick it up. After walking quite a bit for 1 or 2 days, we were not really satisfied with what the remote sensing images were telling us, so most of our actually pairing was conducted based upon Sharon Hood's char ratings near the ground lines ranking, which is this. And so again, our response variable is radial growth during the entire growing season, but as well separated between spring and summer of early and late wood. We collected 160 cores from 80 trees total, 40 each, and double core each tree. And our predictors were the DBHs, tree height, char heights, minimum, maximum, bunch of different variables. We also measure the basal area factor using different values for different species surrounding each of these focal trees as a proxy of tree scale competition. We also look at organic matter death, again thinking about the soils that were burned or sinking, as well also gradient of slope. April and other people in the lab, thank you so much. April again spent hours and hours, Andrew knows well if he's still around, hours and hours, days and days, weeks and weeks, sounding, processing, counting, delineating, cross-dating, and this is where we are. All the cores have been already cross-dated by early and also separated by late and also separated by whole range, so that again we can look at questions associated with just spring or just summer or the entire growing season. And the next pending steps where April is right now, it's developing chronologies. We roughly core only the last 100, 120 years or so. Some of these Douglas-firs we would need several of us to go around, so we're not interested in those questions going back in time, and also we didn't have meteorological weather station to actually do the analysis. And so that was enough. We're going to be looking at growth trends by period. We know that after 2000, for the most part, the Western US have been actually in an increasing aridity trend, and we would like to test for that, how trees are actually growing, both biomass-wise, but also how they are growth in terms of their sensitivity to climate. So we're going to be looking at climate relationships, again, by season. Some of the very preliminary field results that we have actually from the field data sheets that we can show here in this corellogram, where in the squares I've highlighted the main takeaways, which are tree mortality is associated for Douglas-fir only with the charring height, which is quite intuitive, with the percentage height that is charred, and also with trees that are snapped, which is also very intuitive. But actually, it's not the case in Western hemlock. In terms of the competition at the tree scale, we found, I think, an interesting story here that we still need to further unpack, which is the idea that higher competitions tends to be associated with larger trees. That is to say that as we have larger trees that actually are being sampled, we see a clustering of usually younger or smaller trees around it. Which makes sense if the ones that are around them are shade tolerant and they're clustering around a shade intolerant tree species like a Douglas-fir. Slope, that is to say, the flatter it is, there is more competition. That is also sensible. Char height is negative, so that is an interesting story here. That to me, in crown scorch, says that the denser those forests, the actually less injuries those trees received. And that the way we are interpreting these results is that because this was a relatively minor conditions in terms of fire weather, we are interpreting those results that denser patches within these old-growth forests provide more shade, and that actually suppressed or ameliorated, at least to some extent, the actual injury of those focal trees. And also, crown scorch, percent crown scorch is associated negatively with DBH. That's to say, the smaller the trees, the focal trees, the higher the scorching. Again, same story, different narrative in terms of the analysis and also the takeaways, respectively, for Western hemlock. We see that tree mortality is associated with crown scorch, but not of whether or not the trees had actually snapped. Focal tree competition was associated negatively with deep bark charring at the base and also negatively with slope. That is to say now that if a tree had higher competition nearby, it seems that it also deterred the actual charring at the base, but did not necessarily explain the scorching of the crown as it did for Douglas-fir. Deep bark charring was associated with higher slope, which makes sense with how fire moves, higher sizes of the trees, which it's a bit counterintuitive, and then also higher height of being charred, which I think it's a correlate of those. Next steps, that seems like a common of this stage right now. We need to finish, actually, the cross-dating is done. This slide has a couple of weeks. Determine pre-fire growth trends, determine climate growth relationships, model tree radial growth responses to drought events, and also looking at the effects of climate and weather variability on post-fire delay mortality at the tree scale of this lower elevation forest. And with that, I would like to thank you.